So hello everyone, hopefully you like cheese and robots. So as we all know, robotics is on the rise. Specifically in industry, robotics, the robotic market, as you can see, is growing exponentially with more and more tasks either being fully automated or moving on to a collaborative scenario where the task is shared between a robot and a human worker. At the same time, that's being correlated with a steep rise in productivity and efficiency, as you can see in the middle. But also at the same time, we're witnessing a major growth in worker stress, worker, not just stress, but a lot of negative effects that you would notice in health-related terms. So just burnout, for example, also dissatisfaction with the work. So the question is, how can we maintain high productivity or improve the productivity, as well as ensure that the worker well-being is retained or is also improved? How can we ensure that this growth in industry remains sustainable for the future? So when we look into the interaction process between robots and human workers, we notice that it follows a more or less standard procedure of back and forth actions. The thing is that the robot actions actually have an impact on the worker. And since we're human, everything that we do, everything that we observe causes some sort of activation in our brains. This activation leads to some sort of psychological change, some sort of mood change, and that leads or translates to a reaction that you can see in the action that we have with the robot, so in the task that we're doing collaboratively. The thing is that most collaborative robots or most robotics in industry right now don't analyze these biosignals. They don't care about them at all. So the question now is, how can we use these biosignals? How can we capture them, analyze them, and improve productivity and also ensure the worker well-being? So, well, the question, as most of the other presentations, is interdisciplinarity. When we start gathering all of these areas that are tied intrinsically with collaborative robotics, we can make sure that we can both capture and analyze the biosignals that I just talked about, and we can see what is useful, what is positive, what is negative, what we can use to improve and make the interaction with the robot more adequate. So, as you can see over there, we can take this information, process it, and build some sort of feedback to give to the robot to adapt itself socially and physically to optimize the interaction to ensure both productivity and the worker well-being. Now, naturally, this has to be done in close proxemics with our industry partners so that we can get both real worker data, real world data, then we can develop our solution, and we can actually apply it in a real world scenario, so we can actually deploy it in the field. So naturally, given that it's an interdisciplinary project, we also have a diverse team. So we gather 6 different researchers from 3 separate institutions, 5 different backgrounds. So that would be psychology, neurobiology, collaborative robotics, signal processing from physics, and also brain-computer interface, because obviously we need to study the biosignals, as I mentioned. I'm positive that this will help us provide a very meaningful and working solution for the problem. And lastly, I want to thank the university and also our colleagues at UC for the initiative of the SEEDS project, and also the Santander Foundation for making it possible. Thank you.